Hello everybody, my name is Miriam, Nayde, Calle, Mamani. I am fourth semester student of the Operating Systems subject from the Systems Engineering career of the Public University of ALTO, and today we are going to dive into the fascinating world of the Boolean algebra. Have you ever wondered how computers process information so quickly? It all comes down to a simple but powerful language, Boolean algebra. Boolean algebra, invented in 1844 by English mathematician George Boole, is fundamental to representing digital logic circuits. Over time, scientists such as Jevons, Schroeder, Huntington, and M.H. Stone have modernized and demonstrated its applicability in various areas, including mathematical sets. In the 1930s, Claude Shannon used Boolean algebra to study switching circuits, which enabled the efficient representation of modern electronic automation tools. Although Boole's work seemed to have no application at the time, in the mid-20th century, Boolean algebra became an essential tool for digital information management. The formulation of Shannon's coding theory and the definition of the internal structure of computers by John von Neumann. Today, Boole is considered one of the founders of computer science in the theoretical basis of the digital era. This branch of mathematics is fundamental to the design of electronic circuits and computer systems. Without it, our favorite device would not exist. Boolean algebra is a method for simplifying logic circuits. Therefore, it is also called as switching algebra. We can represent the operation of logic circuits using numbers by following some rules as laws of Boolean algebra. We can also make the calculation and logical operation of circuits even faster by following some theorems, which are known as Boolean algebra theorems. A Boolean function represents the relationship between the input and output of a logic circuit. Boolean logic allows only two states of the circuit, such as true and false. These two states are represented by 1 and 0, where 1 represents the true and state and 0 represents the false state. Boolean algebra laws and identities. When formulating a mathematical expression for logic circuits, it is important to have knowledge of Boolean algebra, which defines the rules for expressing and simplifying binary logic statements. Fundamental laws or becomes the sum of variables input to obtain a result output, and becomes the multiplication of the factors input to obtain a product output, and not is the inverse of the input. Properties of Boolean algebra. It has 9 properties that will help us to resolve the circuits and take them to the smallest expression. Commutative, where the order is not important. Associative, with which we can associate. Distribute, help us to simplify or extend the exercise. The neutral element simplifies when we add with 0 and multiply with 1, leaving only the variable. Absorbing element, any variable added with 1 is 1 and multiplied with 0 is 0. Law of the complement is if they are added we get 1, and if they are multiplied we get 0. Idempotent, adding or multiplying the sum variables give us the same variable. Simplifying, and finally De Morgan's theorems, being both the negative of variables. Today we discovered that Boolean algebra is more than theory. It is an essential tool that brings modern technology to life. If you like this video and want to learn more about how mathematics drives innovation, don't forget to like my video. Thanks for joining me on this mathematical adventure. Until next time, future engineers of the digital world.